Good evening, everyone. I am Emin Kareem, and I humbly welcome you all joining today's webinar that is hosted by AI DataYard. To introduce, AI DataYard is an international e-learning platform that provides certified training, digital solutions, as well as job opportunities in fields such as artificial intelligence, data science, machine learning, and so on. Thank you to everyone who has joined, and I hope we can all leave having learned something new today. The topic that we will be discussing and talking about today is securing data driven systems from cyber attacks using blockchain technology. A lot of businesses nowadays are transferring a lot of their data and transactions online that leaves a lot of their precious data and themselves really susceptible to cyber attacks, which leads to them being and their data being really vulnerable. To further elaborate and talk on this, I am pleased to announce our guest speaker for today, that is Mr. Faizan Safdar. Mr. Faizan Safdar is currently a lead full stack software engineer at Educative, but he has Educative. He completed his BSc from LUMS, Pakistan, and his master's from Koc University, Turkey. He also has won Best Master Thesis Award from IEEE Pakistan, IEEE Computers for five journal publications in blockchain technology. Hi, Mr. Faizan. How are you doing today?
Hi, I'm doing well. How are you?
I'm doing
And how is
good. Thank you
everyone?
so much. Thank you so much for taking your time out for doing this with us.
Oh, you're welcome. Yeah.
So, shall we start then?
Yes, we can.
All right, then. Here you go.
Okay. Hello, everyone. My name is Faizan. As he said already, I've been introduced very well. Thank you very much. And today I'm going to present on securing data-driven systems from cyber attacks using blockchain. And I hope that you all learned something new from my presentation. So let's begin. So this is going to be the overview. We will start with introduction, and then I will talk a little bit about blockchain. Then we will dig into the blockchain trends that are in the industry and in the research and in the academia. And then we will look at some of the cybersecurity threats, including attacks like ransomware or DDoS attacks. And then we will see like how blockchain can actually help us, mitigate those attacks, and what are the application of blockchain in these scenarios. And then I will end up my discussion with a conclusion, and if you have any further questions. Okay, let's begin. So what is blockchain? Blockchain is a distributed ledger which is consistent of transactions, and it is split into different blocks which are physically present all over the network and can be validated. So that means that we will further get into that in the future slides as well. But what happens is that each transaction that is created, it is present all over the network, and with like every node has that, so it can be validated, it is authenticated, and it can be used in the future. And it is immutable by its nature, because even if someone changes something on one node, it will not reflect on the other nodes. And we will see how that happens in the future as well. Okay, how does blockchain work? So first of all, a transaction is created. A transaction should be authenticated by the person who is creating that transaction. So every person has their private key, or you can say they have a passcode that they have to use to create the transactions. That transaction becomes part of a block. A block represents that there are some transactions that are created. So for example, I can say that I sent money to my friend. Okay, so that is one of the transaction that I created. That transaction become parts of the block, and that block can have multiple number of transactions. That is done to actually reduce the size of the information that a blockchain has to keep. We will not go into the details of the blockchain in these slides, because this is just the overview of the blockchain and its application. But if you are interested, you can actually go into the details of how blockchain works. Moving on. That blockchain is then sent to all the participants. As I mentioned earlier, there are many participants in the blockchain network. So everyone gets that transaction. Now, there is the most important part. Every node actually validates the transaction, and how it does it is amazing. So it looks at 50% of the other nodes, and it sees that if other 50% of the nodes have the same transaction or the block or not. And if there are, like, it goes with the majority, you can say. So it's like democracy. So if the majority of the nodes are saying that this transaction is not part of the blockchain, it will reject that transaction and it will not validate it. And if they are saying that it is, then it will accept it. And that makes it the most secure, you know, data database, you can say. It is the most secure database in the world, because now even if you want to attack something, you have to own at least 50% of the nodes, and there are millions of nodes out there, millions and millions of the people who are creating the transaction and who are validating them. We call them miners. Once that transaction is validated, now there comes the part why those nodes are part of the network. Why would they be part of the network? They don't have any incentive. But here comes the meat for them. So they can actually be rewarded for their proof of work in form of cryptocurrency or in any other form. Now that everyone is happy and that transaction is created, that block is now the part of the blockchain, and it will remain the part of the blockchain for the rest of the eternity. So it's not going anywhere. Once that becomes a part of the blockchain, the update is distributed all over the network. That means that even if there is just one node who created that block will be part of every other node now. Now the transaction is complete and you can move forward. So this is the overview of how the blockchain works. Now let's just see, like, what are the features of the blockchain. So consensus is a big feature of the blockchain. That means that every node in the network, it will always have same kind of data. So as we can see in this slide, that once the transaction is complete and the block is created, that block is sent to all the nodes in the network. That means that everyone has the same data, or they will eventually have the same data once they get the updates. It's unique. So every transaction or the block that is created, it's created with a specific hash, which is a cryptographic function. You can look into it further. Hence, it makes it unique. Authentication, as I said, for you to create a transaction, you need to have that passcode or you have to have that key, and that makes it authenticated. Validity. Now this is the important part where you can actually trust the blockchain. You can trust the privacy, you can trust the security of the blockchain through its validity. So what it means is that if you want to validate if the transaction was created, so my friend comes to me and he says that, okay, Faizan, you didn't send me the money. I can just go to the blockchain and I can ask them, okay, validate my transaction. Did I send this money? And the blockchain will give me the answer, and whatever the answer is, that means that I sent the money and he must have received it. Immutability, as I mentioned earlier, there are many nodes over there and every node has the data, so it's very hard to actually change any transaction in there. Moreover, there is a cryptographic function which you have to work for, and it's very hard. It's even if you to solve that puzzle only once, it takes hours and hours. And to change one transaction, you have to change the thousands of the transactions coming before that transaction and the coming after that transaction. So it's nearly impossible to change anything on the blockchain, and it is resilient. So there is no one point of failure. So it's a peer-to-peer network. Every node is individual. So no one has, it's not like a bank that, like, it has its network and everyone is using that network. Like, so there is no one point of failure. These are some of the consensus algorithms that are used right now. Most important is the proof of work and the proof of stake, which means that either you have to solve some puzzle or you have to show some stake. You have to become part of the blockchain. You have to buy some blocks, or you have to mine some blocks. You show that, okay, I have a stake in this blockchain. That means that if their blockchain goes down, then I'm going down with it. So I don't want to do that. So that is important thing. Other ones are also important. Proof of capacity is being used a lot in the field of energy trading. But like they are not that important. There is a Byzantine fault tolerance as well, which is used for hyperledger, which is another important blockchain, but we will not go into the details. Another important aspect of blockchain is a smart contract. So, what it means that it's a computer program that is executed once there are some specific criteria being met. So, for example, I am selling some books. So what happens is that there is a buyer online, and I don't trust that buyer. If I send the book to them, it might be that that buyer runs away. So what happens is that I sign a contract with that buyer, and I'm like, okay, uh, if I send you the books, you have to give me the money. If you don't do that, then I'm gonna run to the police, or like I'm gonna make a lawsuit against you. It's the same. So whenever there is some whenever there is some transaction being made, if there is a book being sent or anything, then you can actually go to the blockchain and you can say, okay, give me the money, I have done my part. And the blockchain will is honest, because as we said in the beginning, that there is nothing to be changed, and it's resilient. So it will make sure that, okay, uh, if the party is fulfilling their end of the bargain, then they will get paid. So it is just one part, type of the smart contract that you can use for the payment options. But there are many other applications. For example, identity management, voting systems can be big part of contract. But when I was doing my research, there were a lot of papers that used to present the voting system using the smart contract. It's amazing. Then you have chain management. Supply chain management means that if you you can validate if some supply was uh, sent to some store or not. Then ride sharing, healthcare, there are a lot of applications of smart contracts. Now let's just dig into this blockchain trends. A very important trend in the blockchain that can be seen is the blockchain for AI and then AI for blockchain. What does that mean? Is that you have decentralized computing for AI, and you also need decentralized storage as well. Another aspect of it is federated learning. You can actually read up more about it. Federated learning means that, if let's say I have some important data and I don't want to share that data. I'm a healthcare advisor. I have some private data um, of my clients. So I have that restriction that I cannot give that data to anyone or everyone. So what do? Still want my data to be used for the research. I want that data to be used for the AI, because it will be important for the rest of the world. So there is a technique of federated learning where instead of sending the data to the model, I ask them to send me the model. I will train that model on my data, and then I will send that to you. And how do we do that? How can we maintain the trust in it? How can we make sure that that person is not actually sending the model, or is not training the model on the wrong data, because that can skew our results? That is very important. So what we do is we can use the blockchain, ask him, then, okay, like, you give me the proof of concept, you tell me that you have the data and that data is all right. So give me some zero knowledge proof, again a cryptographic term that you can dig into. And then you see, okay, if that data is fine, then I can send them the model, and then that model can be used to train. On the other side, there is AI for blockchain. Uh, I will just talk a little about it because that's not part of the topic. That means that you can actually further secure blockchain using the AI. So there are many transactions. Many of them can be legal transactions. So you can actually use AI to secure the blockchain, or you can predict what attacks can happen on a specific blockchain, because like although blockchain is very secure, but it is still prone to some cyber attacks. So that is another aspect of AI, but we will discuss how the blockchain can be used in AI and data. Again, the very important blockchain trend is healthcare. So you have a specific AI in the middle. Again, that can be the data. Okay, and now you are getting the data from the radiologist, the patient, drug maker, physician, and you want to keep that data on the one place. And again, blockchain is very good tool for the incentivization. So you can actually use blockchain to pay the people as well. You don't have to go to them and give them, or you don't have to get their data information about their banking or their credit card. You don't need anything like that. You just need them to be part of the blockchain, and you can actually give them the money based on the data they provide. You can analyze that data as well using the smart contract, because you can write a smart contract in such a way that you analyze the data, and then once the data is analyzed and you are sure that data is useful, then you can pay. Another important aspect is over here is the privacy and the security. Again, if that data is on the blockchain, that means that you cannot read that information until and unless you have that private key. Because and the second thing is that you cannot change it. The third thing is that it is private in the way that no one else is going to get that information. Only the people that you are sharing that data with will have that information. Decentralized applications. So this is the bigger picture. So decentralized applications actually cover everything. So there are a lot of decentralized applications. How they work is that, so a usual application will have a data center, and then the ISPs, internet service providers, and then every end user is connected to them. So if you want to use the application, you have to use the application through the data center. They can be in the cloud, they can be your private network. The decentralized application is peer to peer. You don't need any centralized entity. You can actually share the data amongst themselves, which increases the privacy, because in here the data center has the control and they can actually look into your data. But over here there is nothing like that. It's more secure, because over here if the data center goes down, then you cannot use the application. But over here, even if one ISP goes down, you can actually use the other ones. Ethereum is actually a very good tool that can be used for the smart contract. For a very long time and for many applications, Ethereum has been used. But nowadays there are like other alternatives. There is Hyperledger, which uses different kind of consensus systems. But right now there are many decentralized applications based on the smart contracts that use Ethereum blockchain network. Okay, now let's just get into the worldwide trends. So there are 202 initiatives in 45 countries right now. 1 year ago, there were very few companies that were using blockchain, but now there are 150 plus companies, and there is more than $1 billion of funding involved in the blockchain, and it's increasing. Trust me, it's increasing with the NFTs involved, and smart contracts growing, and there are new kind of blockchain networks coming along. This number is going up and up, and there is a lot of capacity. You can actually tap that capacity, and you can earn as well, and you can get into that business. Japan, you can see that Japan is turning to blockchain. They are using blockchain for energy trading, and then electronic vehicles. And like Australia is now turning, and Europe is using blockchain for energy trading. So there are a lot of applications that are being used for blockchain all over the world. Now let's just get into some kind of, as I mentioned earlier, that there are different consensus systems. So I just wanted to show the market. So for example, if someone wants to get into a blockchain business, it will be helpful for them to understand what type of consensus system they should use, and what type of blockchain network they should use. So as we can see that most of the market is using more proof of work. So there are some Byzantine fault tolerant as well, which is Hyperledger, but most of them are using flow proof of work, which is Bitcoin blockchain, you can say, or Ethereum, you can say. And over here, you can see which blockchain network is being used the most, and the Ethereum is the winner. So if you are new to this, these are your go to technologies. Now let's just talk about some cyber attacks and data breaches in the past. What can be the cyber attack? So cyber attack is something, uh, if someone gets the information or gets the access to the computer or something for a specific time which they shouldn't have, then that considers as a cyber attack. So there are multiple types of cyber attacks. There is ransomware means that they will encrypt your data, or they will keep your data for a while, and they will ask you for money to actually get that data to yourself, or they will delete it. Malware is there's no money involved in the malware most of the times. It means that it will just infect your data, and everything will be lost. If it gets into your machine, then you are gone. Phishing is a social engineering type of the attack. It means that it is mostly targeted to the people who are not that knowledgeable. That it means that it will create a replica of a very well-known website, and then it will ask you for your credentials. So for example, if I have my data over the Google Cloud, it will create a replica of a Google Cloud, and someone can send me that and ask me to log into that. In that case, they will have my credentials. They can go into the my Google Cloud, and they can actually delete everything. Denial of service is a very big problem with the centralized systems, that if you have one machine and there are many requests coming in, your machine might break. And if that breaks, it will not even serve the valid requests. So that means that there is no service, so hence the denial of service. And the single point of failure, as I mentioned, there is a lot of problem with that, because if you have just one server involved, if that goes down, all of your users are gonna struggle, and they will have problem. And by one server, I don't mean just one machine. It can be multiple machines, it can be a data center. But because if once the malware gets into your data center, it will infect all of your machine. It will not just affect one machine, because it can travel very fast. So by one server, I means that even if you have a big building with a data center, it can go down if it's a single point of failure. Now let's just talk about some data breaches in the past. So there was a big data breach in Uber, where the names and driver license of around 600,000 drivers in the United States were out in the open, and some personal information of 57 million Uber drivers and drivers around the world was out, and their mobile numbers, which is a big data breach, and Uber had to suffer a lot of money loss in that. There was another very big scandal about the Target, where the Target's information was stolen. So what they did was they breached into their POC, point of sale, and then they actually hacked into that, and then got the information about the credit cards and the debit cards. And there were 70 million customers record that they had. And it costed the company around $18 million. And hence, like, again, a very big application of blockchain over here is to use the blockchain for the payments. There is no credit card involved, and these kind of attacks can be mitigated. Equifax is another company. It's a big company, and it had to suffer data breach back in 2017, and it's still paying the amount. So on the right side, it says that there's I can't even say this number, it's a big number, of in dollars in settlements, and is still paying the people on their website. If you go, they will ask you for your information, and they will say, okay, if they match the information, they will pay you up. So they are still paying the people, because it was around 147 million people involved in that data breach. So it's very critical. So as you can see, like, we have to do something about these things. Let's just talk about a little bit of cyber threats right now. The ransomware attacks have risen like 350%. I was reading yesterday about the phishing attacks as well. I didn't mention it over here. The phishing attacks, because of the COVID-19, has increased in like 600% of the time, because everyone is getting the emails regarding free shorts, free results, testings, and all of those are scams. You believe them, you click the link they have provided, you make an account or something, you give your credit card information, and boom, you are gone. So all your information is with them, and then they can use it in any way. So the ransomware attacks are estimated to cost $6 trillion. Can you imagine? So $6 trillion, more than the GDP of Pakistan. So it's a lot. So it's a very big money. It's like nearly, it's more than the GDP of many European countries, like Spain and Portugal. Like, it's a big number. So we have to do something about it. The number of breaches incidents by source. So you can see that malicious attacks are increasing, the accidental loss. So it's not just about the cyber attacks we are dealing with. It can be like, it just happened to me like 2 days ago. Like, I deleted my Google Chrome profile, and all the data was gone, and I was in a deep problem at that time. So it can happen as well. And there are like many other unknown attacks that are not mentioned in the report. So now let's just look into the role of the blockchain. Oh, where did that slide go? Okay, I will just talk about it. So the as we mentioned that there are many problems with our system. So there are many threats that are involved. So how can the blockchain help? So first of all, it's the payment. So if you are creating the payments using the blockchain, it actually reduces the vulnerability. So you are not using any credit card, you are not using that data. That data is not going anywhere. The second thing is the hashes and the cryptography. Now, let's say you are using the blockchain as your database. Everything that you are storing on the database is cryptographically secured. That means that no one else can actually look into that data, and hence that data is secured. So all the data-driven systems around the world, by data-driven systems, I mean the system that depend on the data. So all the machine learning system, AI systems, smart cars, the healthcare systems, they can actually use the blockchain as their databases and actually keep the data over there in the more secure way. Because as we saw in the earlier slides, the systems that use a single point of failure, that use this central database, they are prone to single point of failure. Also, if the attacker gets on hold to that machine, it can get the information about the data over there, and that data is going to be a big problem, because then you will be paying people in for because of that, and that is going to cost you a lot of money. So instead of that, if you keep the data over the blockchain, that will be cryptographically hashed, and it will be secure, and no one else will be able to, even if they get into the network, they will not be able to see like what actually is present over there. Another use of blockchain is its resilience and backup. So even if you lose the data because of your own problem, by mistake, that data is replicated all over the network. So it is present on multiple nodes. As we mentioned earlier, the blockchain actually keeps the data all over the network on several nodes. And even if one node actually lose that data, or that node is not available, then you can actually get that data from the other. So it is the constant backup that is being created for you. You don't have to take care of that. You can actually do that yourself, but you don't have to do that, because again, like, there are several consequences involved. Even if you are creating the replica, then the people who have information about the data centers and the databases, they might know that you have to take care of the consensus system. You have to take care, even if you are creating a microservice or anything, you have to take care that all the messages and all the transactions are created in a in in a same order, in some order, so that there is no uncertainty in the database. But with the blockchain, that consensus is given to you as well, so you don't have to worry about that. There is another important thing over here, which is authentication and authenticity. There is a little difference between them. So authentication means that you can only create the data or the transaction, or you can only access it if you have a specific passcode, as I mentioned earlier. But authenticity means that whatever data you are getting, it was actually created by a specific person. So let's say if I am sending the data to a healthcare service, and they want to see like if that data was actually generated by Faizan, they can actually do that. So that's not a problem. So these are some of the ventures where the blockchain can be very helpful in securing the data-driven systems. So I will just conclude with some final thoughts. Blockchain is the most trending new age technology. As we have seen that there is a lot of money involved in there. Blockchain can be a very good tool for data security. Blockchain can also be very important for the overall security and privacy of your network. Blockchain can be used for threat intelligence, backend and recovery, and threat resilience. Okay, there you go. This is the slide that I was talking about. So I'll just go over a little. So the blockchain for backup recovery, blockchain for privacy. You can see like it's impossible to crack the anything over the blockchain. It's very impossible to undo that data. You can actually use it, have the traceability and immutability. Traceability means that you can actually see the where the data was originated from. So let's say your data has been sent from multiple participant to the multiple participants. Then that data will create its transaction over the blockchain, and you can actually go back and see like where that data actually originated from. And as I mentioned, that you can use blockchain for authenticity and authentication. That's all from my side today. Thank you very much for listening to me, and I hope that you all gained some new information and knowledge. Now I'm open to the questions if you have any.
All right, great. That was really wonderful and really informative. I, for
Thank you.
one, learned a lot. But if we'll see if we have any questions. Someone is willing to have a question. Let's see. You can just please write it if you have any question, and we'll read it out loud and then answer it. All right. I suppose there's no questions. Then that was, I really did genuinely enjoy your session. It was really informative and really helpful. Unfortunately, that is all the time that we have for today. Thank you very much, everyone, for joining. And I thank you very much, Mr. Faizan, for providing such an informative and helpful session. I sincerely hope we all are leaving having gained something new and a new perspective to look at. Make sure everyone to follow AI Data Yard on all social media platforms and keep an eye out for other webinars to come. Make sure to keep and for other webinars to come, and you can expect much better and much more content from us. But for today, that is all. Signing off, Aman Kareem.